Here we have a 32-bit carry skip adder designed using 4 8-bit blocks. In an iterative logic array, data proceeds from the least significant bit to the most significant bit. Our task is to identify the critical timing path and to estimate the worst-case propagation delay. Let's have a step-by-step look at what happens after data is made available to the adder from the input registers at the clock edge. All data and the input carry, shown here in green, arrives simultaneously. In the first step, bit generate and bit propagate are formed in parallel for all bits, which takes a certain time that we denote TPG. The worst case scenario is when a carry is formed in the least significant bit, that is when G1 is 1 and P1 is equal to 0. Let's highlight the critical timing path starting from the carry generated in the least significant bit until the most significant sum bit is generated, so highlighted here in red. During the following 7 steps, group propagates are successively formed in an iterative way, rippling through the blocks to form block propagates when they reach the block propagate outputs. Block propagates are now formed, and the first block sum has become available. Time so far is now TPG plus 7 times the delay through the AND OR gate used to ripple the carry through the adder. Block 2 can now start working, since its input carry becomes available at the output of the first multiplexer. Block 3 can now start working, since its input carry becomes available at the output of the second multiplexer. And after another multiplexer delay, block 4 can now start working, since its input carry becomes available at the output of the third multiplexer. Through the following steps, the input carries now ripples through the 3 most significant blocks to gradually form the sum outputs. Second block sum becomes available. Third block sum becomes available. And finally, the fourth block sums become available and addition is completed. We now have a formula for the delay through the carry skip adder, which is the sum of TPG, which is the setup time to create the bit propagate generate signals, plus 14 times the AND OR gate delay, 7 times here for the carry or the propagate to reach the first multiplexer, and 7 times here from the output of the third multiplexer until the final sum is derived. And we have the delay through the 3 multiplexers, 1, 2, and 3, and finally the XOR gate delay here forming the final sum. So addition completed and video completed. Thank you very much for listening and watching.